tells me that's a zip device. And at this point, that's pretty much all that I want to know. So what I do is I send all the different kinds of zip messages, and once I get a response, I know it's a zip device. I don't care what kind of response I got, as long as it starts with like the valid zip response header. And I can do basic banner grabbing, like shown before. You can just look at the user agent header and says, okay, this is running zip express router, or this is a SNOM phone. You can do that pretty easy. I want to do live demo, but unfortunately I don't have internet connectivity here. So I'm just going to show you in the screenshot. So what you do is you can specify either an IP address range, host name, you name it, and we'll start sending ICMP packets and try to see if the host is up. You can turn that off, much like on Nmap with the -P0. And then we'll just start sending zip-based messages. And the moment it gets back a zip-based message, it lists the device as zip-enabled. As you can see, I scanned 8 hosts, 7 of those were up, and 5 were zip-enabled. So that's a pretty good hit ratio. I got that hit ratio since I'm scanning just IP address ranges that actually belong to one of the ISPs in Germany that offer voice over IP services. The market in Europe especially is really limited. In Germany we have like 5 or 6 big ISPs, and they are all offering voice over IP in addition to DSL networks. So you do get a dynamic IP address, but you know the IP address range where that DSL router is hooked up to. And that DSL router happens to be voice over IP enabled. So if you're looking for voice over IP enabled devices, all you have to do is just get an ISC, look up some random guy and see if his host name is in some DSL IP address range from a certain ISP, then start scanning that class C network, and the hit ratios go up to like 90%. 90% of the devices you're actually scanning are voice over IP enabled. So usually if you're just scanning random IP addresses, it's really low. Like everybody's running HTTP server on the Linux box at home, but there's just so few people that run asterisk on their home box. So knowing good IP addresses and knowing how to find locate devices fast is really important to actually do any attacks, since if you can't find any devices, it's going to be really hard to do attacks. What are the issues? That was pretty easy to do in the first place, but what are the issues that we currently have? Most of the devices we have are DSL routers, so there are no net issues, no firewall issues whatsoever, but lots of interesting devices, like soft phones running on Windows, are behind a net. And if you manage to trigger a bug in them and just probably execute random code, it's worth way more in terms of hack value in comparison to just your DSL router. So you have to get through a net from the outside to locate the device, to fingerprint the device, and actually exploit it. Getting through a net is kind of hard, and you can take your IP address, but you won't get your response back. So getting the response back is one of the more difficult parts. Even if you manage to get through a net, there might still be a firewall. Like, we're making our vendors of zip devices implement firewalls so that they will only accept zip messages that are coming in from our zip servers. There's no reason for some random guy to send random zip messages to some DSL router. There are some use cases, but you can just take a hot hook on your web interface and turn it on. But usually you don't need that. So it's really hard to get around firewalls if there are firewalls. But this is what I came up with, and it's not being automated in the SMAP tool yet, since I'm really looking into how to get it really automated. What you do is you do have some zip client behind a net or a firewall, and that will only speak towards your zip server, and it will only accept incoming messages from your zip server. So if I spoof the source IP address of that server, I can inject a packet, but the response would just go back to the zip server. But if I do change the signaling part, I can make the device send the packet back to me. And at the same point, since it's kind of a new communication establishment, it would open up the firewall. So I can from that point on directly send packets to that zip device, since the firewall in between just opened up the port. But it's really hard to get it right, and at some points you have to deal with the zip domain names that you just don't know at that point. So it's not being automated, but I'm planning on getting it done sometime in the autumn, and that should be available on SMAP then. So now for fingerprinting, generally, yeah, you know fingerprinting, active fingerprinting, this short primer, you just craft a random request like for OS fingerprinting and using like, Nmap, you just craft a request and you get a reply back, and based on the reply, you expect you've got a database and just check the reply against the database and say, okay, that's sort of device. If you're not talking about TCP flags, there's a paper called ICMP Uses in Scanning, which is pretty good. It uses ICMP messages. For instance, you send an ICMP netmask request, and if you get a response, chances are pretty high it's a SunOS box. You can trigger all sorts of bugs by sending random messages, but this can be detected really easily since you're sending superfluous messages that usually don't show up in regular signaling. So if you're doing passive fingerprinting, you just look at the traffic you're already seeing. But the downside is you won't be able to trigger any bugs, since if you're just looking at regular traffic, there are hardly any bugs in there, since people tend to fix bugs if they can't make a call. So for zip fingerprinting, why do we actually do it? From an ISP point of view, I like to know which devices are in my network, since if you do have some bad device, like sending invites all of the time, you just try to drop those invites or drop some of the invites, drop some of the messages to lessen the load and the impact. And eventually we believe that devices or clients that are going to inject spit messages into our network are going to look a lot different than regular DSL routers. So just by identifying those devices, we try to figure out, okay, that might be a split one, okay, that looks like a regular client, so let that one in, and that one, yeah, might be bad. But on the BlackHat side, you can still disguise your program. You can just look at regular signaling and make your client look like a regular client. So making fingerprinting pretty much impossible. The HoneyNet project uses the Nmap fingerprinting database to mimic the behavior of different devices. And you can do the same with clients. But yeah, we haven't seen it yet, since you won't be able to see it anyway. But we haven't hardly seen split yet, so it's we believe that that's gonna happen in a couple of years. But if you're scanning and locating zip devices, you want to know what kind of device it is. Like I said before, it might be a big IP-based PBX that has like 120 lines connected to that, or it might be just your home router that has like limited outgoing lines or whatever. So as a BlackHat approach, I would have to locate devices as fast as possible, since there are way more IP addresses out there and web servers out there than there are voice over IP devices. And I do want to fingerprint those devices and have to do it actively, since I won't see any traffic from those devices if I'm not sending traffic to them and looking at the responses. But from the BlackHat approach, looking at ISP, I want to have a passive intrusion detection system or prevention system which really can cope with thousands of concurrent calls. So that's different approaches, but I thought, okay, I'm just going to go with the BlackHat approach and then, okay, figure out my way how to get all the knowledge and get it implemented in a passive system. So for passive fingerprinting, what do? You just look at the headers you're getting in response. Like, does some certain header actually exist? What's the order of headers? How does formatting look like? The RFC is pretty loose on some stuff, and companies tend to implement it different ways. Or I can look at like the TTL value on IP. It's an 8-bit value and it's supposed to be set like to 64 to 255, but nobody cares if it's set in 28. It's perfectly legal, and that's what Windows is doing. And you can identify a Windows machine based on the TTL. And the same is true for zip. So for active fingerprinting, you just fire random messages at the box, and it might respond or might not. And much like Nmap, based on the fact that you got a response or didn't get a response, you can look it up and compare to your database and say, okay, that device looks like a Cisco phone. The messages that I'm using are limited. It's actually 7 messages right now. It's a regular options request, then it's an options request that's missing the zip colon prefix to zip URI. Some devices don't understand that notation. It's actually broken, but some devices just get around that and still respond. Then I've implemented something called new method, which is an invalid method, and response should be 501 not implemented. but sometimes you just get back 400 pound or something. That's a good way to do fingerprinting. Then you just do an invite, and that might just say, okay, that extension you're trying to reach is not registered in here, so you get a 404 back, or you might get 100 trying back saying, okay, I'm trying to reach that party you're trying to reach. And provisional acknowledgement, which is hardly supported, unfortunately, and the zip ping request, which is specifically written to act as a kind of keep-alive mechanism and to locate devices. You can see the source code and how the messages look like in the source code. And there's, it's pretty easy. There's some documentation how to add more requests if you want to do more of that. And yeah. So how does SMAP look like? You just add the -O option, and if you're playing around with that, you might try the -L for learning mode. I just can't show it to you since we don't have network over here. And it's just going to start sending the very same messages it sent before, but instead of just stopping at the first zip message, it sends more zip messages, builds up a fingerprint, then compares it to the database, and based on the database tells you, okay, that's that kind of DSL router, that kind of DSL router. And as you can see, for the AVM Fritzbox, which is the pretty much most common DSL router in Germany, the company sold 10 million units last year alone, and we've got 30 million households, so pretty much everybody has an AVM-based router. You can even narrow down the firmware version just to a couple of releases, just by sending 7 messages. This is the same approach Nmap is doing, and there might be better ways of doing that, but until now, it's just fine. It just works with 7 messages. You don't have to have any, like the ICMP stuff Ophir was doing, you don't have to have real trees and base your next request on your previous request to actually get a fingerprint. It's just 7 messages, and the hit ratio is really, really good. And you're actually able to get to DSL vendors or DSL router vendors and say, okay, you're running Asterisk, we want the source code to that device before we actually looking at shipping that. And they were saying, okay, we're not, our box is not based on open source, and you just did a fingerprint and say, okay, you're running Asterisk. No questions asked. And at some point they just figured out that their guys in Asia were really using Asterisk based on Linux for the DSL router. So yeah, we put some pressure on them, and we're going to get the source code sometime. At that point, I got distracted since I was looking at fingerprinting, and I was only looking at certain headers. But if you look at zip messages, you're going to have some random values in here. Like Mark was copying the call ID before, and the to and from tag. There's no to tag in this message, but he had to copy that ID, and he had to copy that to actually tear down a call. Sorry about that. And I was looking at those numbers and thought, okay, some of those call IDs just look like timestamps. Some of those tags were just like incrementing numbers and stuff. And I was like, okay, are we actually able to, guess how random those numbers are and guess numbers and actually tear down calls without knowing anything about the device? Actually, it's possible. So we do have unique strings in zip signaling. The most obvious one is the call ID, which is used to identify a call. And if you're using call forking, you do have the to and from tags that become important since the call ID still stays the same. But if you know the call ID, you can just send a cancel or buy request to device and say, okay, please do cancel that call. And most of the devices just look at the call ID in their internal database, the Essence does, and say, okay, I'm just going to go ahead and cancel that